So for the given circuit, we need to find voltage drop V1 and voltage drop V2, and we can see that there is this current source of 30 milliamps, and so the arrangements here, these two resistances, 3 ohms and 3 kilo ohms and 1 kilo ohms, they are in series, and these two are in parallel. So we have, for the current source, we will have, once the current 30 milliamps current is coming at this node, it will have two parallel paths. One is this and another one is this one. So what we should do first, we should try to find what is the total current here. So if we call this one, let's say I1, I don't know, I1, and this one I2. So we need to find I2. In order to do that, we need to find what's the equivalent resistance of these two parallel resistances. So 5 kilo ohms and 20 kilo ohms, these two are in parallel. So the equivalent will be 5 times 20 divided by 5 plus 20, which is 4. So we have 4 kilo ohms here, and these two 1 kilo ohms and 3 kilo ohms, they are also 4 together. So what happens is, this 30 milliamps current, when it comes here, it will have two parallel paths, and each of the paths have the same resistance. Basically each has the same resistance. So one is 4 kilo ohms here and 4 kilo ohms here in this path. So the current 30 milliamps will be divided into half, and 15 milliamps will go in this direction and 15 will come in this direction. So V1 will be, since this is a series path, the 15 milliamps current will flow through the 3 kilo ohms resistance as well, and V1 will be 15 times 3, because V1 is the voltage drop across the 3 kilo ohms resistance, so that will be 45 volts. So that's there. But this 15 milliamps current will go through these two branches. So we will have to apply current divider rule to find what is the current through the 20 kilo ohms resistance, because the voltage drop across that is our V2. So if we call that, I don't know, maybe I20, the voltage drop, the current through the 20 kilo ohms resistor, let's call that I20. So that will be the total current, which is 15 milliamps, divided by sum of the two resistance of the two parallel paths. So one is 5 kilo ohms, another is 20. So 5 plus 20, and multiplied by the other resistance. Since we are trying to find the current through the 20 kilo ohms resistance, we will multiply by the other resistance, which is 5 kilo ohms. So that will be 75 here, 25 here, so that will be 3 milliamps. So the current through 20 kilo ohms resistance will be 3 milliamps, and current through this resistance will be the remaining 12 milliamps, basically, because 15 is coming here and 3 going this way, 12 will go that way. So we don't need that. We need what is the current through the 20 kilo ohms resistance, and that is 3 milliamps. So that voltage drop V2 will be that current, which is 3 milliamps, times 20 kilo ohms. So we should notice it was true for the previous for V1 as well. The current is in milliamps and the resistance is in kilo ohms. So when they are multiplied, the voltage is volt, because that is milliamps, 10 to the power minus 3 amps, and this is kilo ohms, which is 10 to the power 3 ohms. So basically the minus 10 to the power minus 3 and 10 to the power 3 gets cancelled, and both of them get cancelled once they multiplied. So that way we just get volts in the unit, we get volts in volts. So that's 60 volts, 3 milliamps times 20 kilovolts. So we can just write, if we want to convert them all in amps and ohms, that will be 3 times 10 to the power minus 3 times 20 times 10 to the power 3. So 10 to the power minus 3 times 10 to the power 3 is 1, basically, not cancel, actually it becomes 1. So yeah, So our V2 is 60 volts.